In this video, we're going to demonstrate an example of a small sample confidence interval that has a target parameter of mu1 minus mu2. The problem: suppose we wish to compare a new method of teaching reading to slow learners with the standard method. We decide to base the comparison on the results of a reading test given at the end of a learning period of 6 months. We have a random sample of 22 slow learners, 10 of which have been taught by the new method, 12 have been taught by the standard method. So here are the scores on this 6-month, post 6-month reading test. And we have 10 new scores, we have 12 standard scores. We're asked to calculate a 95% confidence interval. There are 3 key assumptions required for a valid small sample test, which are the 2 samples are randomly selected in an independent manner. Both sampled populations have distributions that are approximately normal. And number 3, the population variances are equal. The equation for a small independent sample confidence interval for mu1 minus mu2 is the difference x1 minus x2, which are the sample means of the new method versus the standard method, plus or minus our t alpha over 2 score times the square root of a pooled variance times 1 over sample size 1 and added to 1 over the observations in sample 2. This term SP squared is a pooled sample estimator for the population variance, also considered to be a weighted average of the 2 sample variances S1 squared and S2 squared. So the way we're going to do this analysis is we're going to leverage the data analysis toolpack, and we're going to go to a t-test 2 sample assuming equal variances. So we're going to click that, and let me clear all these fields here. And we're going to say variance, or variable 1, excuse me, are these first 10 scores. And let me make sure I get them in the right place. We'll go ahead and clear that. Variable range 2, here are the 12 scores. The hypothesized mean difference is 0. We're not using labels, we're not going to check that. Our alpha, as defined by the 95% confidence interval, is 0.05, and we're going to put our output right here in this block. We're going to click OK, and here is our data. So we have the means of variable 1 and variable 2, which is the new and standard methods. Okay, so x1 minus x2 is simply this mean minus this mean. Okay, and we can clean that up a little bit. The rest of this, so we need this t alpha over 2, which is based on n1 plus n2 minus 2 degrees of freedom. So we have n1 of, which is 10 points, n2 is 12, that's 22 minus 2. You'll see here that Excel gives us the right number of degrees of freedom, which is 20. It also calculates our t alpha over 2 score. That's this line right here. Okay. It also gives us the pooled variance, which I explained just a minute ago, that being the weighted average of the 2 sample variances. And so now we have all the terms we need to calculate this whole right-hand side of this equation. So we call that either the margin of error, it's also called the sampling error. So we're going to say it's equal to, we're going to click this term, this t alpha over 2. We're going to multiply it by a square root, and then we're going to hit our pooled variance times parentheses 1 over N1 plus 1 over N2. We need to add another closure parentheses, and here is our margin of error. So now we have this mean difference, and here is the margin of error. And then we calculate our lower bound, which is equal to this term minus this term. And our upper bound is equal to this term plus this term. Okay, and just again clean that up a bit. And so our confidence interval goes from a lower bound to an upper bound. So what conclusion do we draw from this confidence interval that has analyzed these two groups of students in the interest of forming a conclusion about the population difference? So the fact that we have a negative to positive range means that it encompasses the 0 point, which says we do not reject the null hypothesis because the confidence interval includes 0. So the conclusion statement is there is insufficient data at the 0.05 level of significance that the new method is statistically different than the standard method. That concludes this video.